Welcome back, physical geographers. We're going to talk about climate and climate change. We're going to talk about some climate classifications and a little bit of impacts on climate change. So we dig into it. So we have a classification system called the Köppen classification system. It tells us about different types of climates, climographs we get into, and then different types of climates: humid, dry, mid-latitude, severe and mild, polar and highland. We notice the groups. The syllabus references those in the readings. Global climate change we'll get into, and then man-made, human, and different types of analysis related to that. We'll talk about causes, anthropogenic, which is more man-made, not natural, and then future types of predictions for climate change. Okay. So, Köppen climate classification system is most globally used based on average annual and monthly values of temperature and precipitation. Kind of makes sense. We have groupings into 4 or 5 categories. The fifth group is 4 of 5. The fifth group is, as we notice here, is classified by precipitation. And each group is subdivided further based on temperature and precipitation relationship. So, pretty objective classification system. So here it breaks down, see A through H. Here's a climograph we talked about in the introduction. So it visualizes, shows details of climate for a specific location. So we can look at temperatures, and then we can look at basically variation by month. Here's a classification system, A through H. Notice A through E, and then we jump to H for each of the categories we talked about. And then here's basically a breakdown of each type of climate. So really 3 types: tropical wet, tropical savanna, tropical monsoon, and group A, which is tropical. In the tropical humid climates, really we have climate controlled by latitude, high declination, consistent day length. Really have it around the equator, close to the equator, rainfall influenced by the ITCZ, which we talked about, as far as 10 degrees north and south of the equator. And we have tropical savanna climate. So extensive area, generally north-south to AF climates. We're seeing a little bit more variation on latitude and a little bit more seasonal shifts as we get a little bit further from the ITCZ. And then monsoon climate, which we talked about being inland and basically reversing weather patterns. High temperatures just before summer monsoon. So we see kind of a change there. And one of our classic examples is India, as far as monsoons changing when the winds blow out earlier in the season, and then as we get into summer, the winds blow in carrying large precipitation. Then we jump to B, dry climates. Covers about 30% of the world's land area. We can see a bunch of the dry climates. No surprise, we see quite a bit of Africa involved in this. We see a lot of coastal terrain and a little bit of inland terrain when we get to Europe and the Russia region up in the top right here. And then we see some coastal, a little bit of coastal when we get to Australia and South America. Excuse me. A subtropical desert climate. See this varying quite a bit. Catch some through North America, a little bit through Australia. Not as prevalent. Examples, we have Atacama Desert. Several cases we have deserts next to mountain regions. Here we see a better map of Australia, subtropical steppe climates. Don't see too many cases of that. Mid-latitude deserts. Once again, not a whole lot of cases of that. Rainfall is most prevalent in the summer with continental warming and instability. See some more samples of that. Mostly seen through Asia. And then here's some mild mid-latitude climates, which we see somewhat inland, and then we tend to see it more on the eastern coasts of areas, mostly due to the westerlies in the north and then the easterlies in the south. Then Mediterranean climate. We tend to use a nice climate that's cooler and has some moisture as Mediterranean climate. For instance, Mediterranean, where we get a little bit north of Europe, or south of Europe by Portugal, or northern part of Africa, which we see right around here. We frequently refer to those regions. And humid subtropical, two more samples of that. Marine west, typically between 40 and 60 degrees north-south, so we're moving more towards the poles. Severe mid-latitude, so we're even going further than that, 40 degrees and 70 degrees north. Then humid continental, we're seeing this quite variable, so mainly we're usually getting inland mid-latitude pressure systems. Examples of this, you get inland or near like the Gulf of Mexico, North America. Severe mid-latitude subarctic. We see this between 50 and 70 degrees north, so that's the furthest we've varied from the equator so far. And then tundra climate, so we're getting to near the North Pole and the South Pole. Definitely Russia. Ice cap climate, so really we're talking about Greenland, Antarctica. Antarctica's on the South Pole. And highland climates, mostly extreme mountainous areas, so we're probably talking about like Himalayas, the Andes, some of the Rockies in the United States. Continued. Okay, now we're going to talk about global climate patterns. So this kind of breaks down the climate zones we just talked about. It has a copper classification on the left side and a description on the right. Pretty handy little diagram of the Earth showing some of the flows. And then here we have temperature trends we talk about spanning back millions of years. We talked about the Ice Age, cold front, and then we talked about some of the human-induced climate change, which we call anthropogenic. Some of it's natural. And then understanding of past climates and causing climate change is paleoclimatology. Kind of got two disciplines pulled together. Study of past events by analyzing tree rings, dendrochronology. And then oxygen isotope analysis. We really have two oxygen isotopes, so essentially what happens with the oxygen. That's really key in terms of what essentially is happening as far as our environment, how much oxygen's in the ice, and we also talked about carbon dioxide being trapped in the ice, especially with Antarctica ice coring, to determine climate change and what climates may have been in the carbon dioxide concentrations we've had in the past. Here we go, the ice cores we talked about, basically looking at oxygen as much as CO2. Ice cores are really conducive as far as what we have had in terms of what has actually existed in the atmosphere for gases. And then there's other analysis like pollen analysis, how much pollen was existed in the environment, so forth. And then we talked about atmospheric aerosols a few chapters ago, essentially contributing carbon dioxide and putting in pollutants and substance matter, which we often see with temperature inversions when we have really bad days as far as breathing in the air and the temperature, and the haze in the air becomes real prevalent. You also have various variations in the Earth-Sun's relationship. We talked about 23.5 degrees as far as the Earth's tilt. That can vary a little bit also, which can change things. Greenhouse gases can fluctuate in addition to natural atmospheric gases. And then role of oceans is oceans really store greenhouse gases. There's oxygen, carbon dioxide that can literally be stored in the water. So then we talked about anthropogenic climate change, so all the different things the human impact could be occurring, both from manufacturing to burning fossil fuels to essentially the impacts it has as far as the polar regions, ice shrinkage, less vegetation, less oxygen in the oceans, which affects other life. And we talk about different models to protect. We have to predict future climate, general circulation models, or system models. Going back to, we only had good weather data since 1950. A lot of these are very generalized. The core samples from Antarctica, that certainly help us go back millions of years. And then some scientists theorize what could happen for future climate change. Obviously, no matter what your politics are, it seems to be a general concern for everybody as far as just not causing too many issues with the Earth. Some current events, some of the things have been said. You know, some people have some theories about, are we microwaving ourselves to death with all the cell phone signals everywhere? Clearly, you know, if we're burning things on the Earth, it's going to, you know, heat the Earth up. So, and then the ozone layer depleting, there's obviously been a lot of concerns about that. So we do need to watch out for our environment for sure. Here's an example of predictive model shown. Kyoto Protocol, some international movements trying to get all the countries in the UN on the same page as far as cutting emissions. Pretty interesting chapter. I hope you're enjoying the class, and we will discuss that on our discussion this week.